Hi there, welcome back. This is Professor Hank, and in this video we are going to take a look at the sorted array-based list data structure. Okay, and for this data structure we're going to look at a list that stores integers, just to keep it on the simple side. And we're going to need to define for our data structure an interface. And we'll need four algorithms, or we'll define four algorithms for interacting with this data structure. Okay, we'll have an insert algorithm for placing values into the list, and that algorithm is going to also have to make sure that the list stays sorted. We'll have a remove algorithm, which is going to have to make sure that, again, after removing the value, that the list is still sorted. Then we'll have a find algorithm, and we'll have a get algorithm for retrieving a value from the list. Okay, so for the sorting, we will assume that the list needs to be maintained in ascending order. Okay, ascending order. All right, and we're going to need some variables to make this whole thing work. So what are we going to use? Let's have a array, which we'll call list. Okay, and then we will have a variable max, which is going to be the capacity of the list. In other words, it's going to be the number of elements in the array, right? So we can just think of this as the capacity of the array. Okay, and then we're going to have a size variable, right? And the size variable is going to be the logical size of the list. Okay, now just because our array can hold, say, 5 elements doesn't mean that the size of the list is going to be 5 values or 5 integers, right? Our list could have 1 or 2 or 4, right? The size variable is going to tell us how many are actually logically within the list. Okay, now for the insert and the remove algorithms to do their business, essentially the big idea is going to be like this. Okay, for insert, what's going to happen is if we've got this array of values, right, and we've got, say, 5, 10, 15, and 20. Okay, let's say that we wanted insert 12. Okay, well, what's going to have to happen is that that 12 is going to have to go in between the 10 and the 15. Okay, well, there is no in between in an array, right? You have one element and then you have the next element. So we're not going to be able to create a brand new element in between the 10 and the 15 here. So we're going to have to fake it. Okay, and so what we mean by that is our algorithm is going to identify that, if we were going to insert 12, the algorithm is going to identify that 12 should go after 10, right, and before the 15. And so to make this happen, what's actually going to happen is we're going to shift the 20 over one element, and then we're going to shift the 15 over by copying 20, one element to the right, and then copying 15, one element to the right. And then we'll overwrite the 15 at the insert position with the value we want to insert, right? So then we'll have our list, 5, 10, 12, 15, 20. Now for remove, okay, the opposite's going to happen. What will happen is that we'll specify some value that we no longer want in our list. Okay, and let's say that we decided we want to remove 15, which is at element 2. Okay, well, the way we're going to do that is we'll end up overwriting the 15 with the value to its right. Okay, and then we'll shift the 25 to take, where the 20s used to be, where its old place was. So we end up doing is shifting all the values to the left, causing 15 to be overwritten with the 20, the 20 to be overwritten with the 25, and then this last value, this last element here, won't matter. We're not going to overwrite it with anything, so we'll end up with two 25s in here, but so what? Our logical list will end at element 3, and so that last 25 won't be considered part of our list anymore. Okay, so that's the big idea with the remove and the insert, and we're going to have to do some shifting of elements. Okay, so let's take a look at the insert algorithm. Okay, insert algorithm. So we're going to have to insert into some list, okay, and we're going to need a value to insert into the list. And then there's going to be a size of the list, and there's going to be a maximum capacity of the list. Okay, so if we're going to draw this out in memory, what's this going to look like? Well, we'll have a size variable. Okay, we'll have our max variable. Okay, then we're going to have an array, which we'll call list. Okay, and let's say that for this example, it's got 5 elements, right? So its max is 5. Initially, the list will be empty, so size will be initialized to 0. Okay. And we're going to have A, whatever A is going to be, okay? All right, so let's go ahead and say that we're going to insert, right? What's the steps of this algorithm going to be? Let's say that we wanted to insert into our list 11. Okay, so what are we going to do? Well, the first thing we're going to want to do is we're going to want to make sure that we've got enough room in the array to put another value. So all we have to do is check to make sure that size is less than max, right? So as soon as size is equal to max, then all of the elements of the array are full with list items, okay, or list members. So long as size is less than that, we've got room. So if size is less than max, then we are free to go ahead and do some insertion. Okay, so to do that insertion, we're going to need to do a couple of things. It could be a couple of steps. We're going to need to identify the insertion location, right? So where are we inserting? Going to insert, and then we have to do the shifting. Okay, and then finally we can do the assigning. Well, one last step too is we'll have to update our size variable too, right? So 4 general steps in this algorithm. Okay, so how are we going to find the insertion point? Well, we're going to need a loop. Okay, so let's initialize a counter I set to 0. Right, so imagine if we've got 10, 20, 30, 40. Okay, what we're going to need to do is we're going to need to find that place. Let's say, we're going to insert the 11. We're going to need to find that place that is greater than 10 but less than 20, right? So our location portion of the algorithm is going to look at the first element and go, okay, is 11 less than 10? False, right? So then let's go to the next element. Is 11 less than 20? Well, that's true. So since 11 is less than 20 and not less than 10, we found where we need to insert, right? We're going to replace the 20 with 11 after we shift the 20, 30, and 40 over, okay? That's the general idea. Okay, so let us go ahead and write that loop, okay? So while, now first thing we want to do, we want to check to make sure that we don't go past the end of our list, right? So we want to make sure that we only look at values that are in the list. So while I is less than size is the first part of this, and right now this is the second part, the value that we want to insert, which we'll call A, so long as that is greater than the value of the element that we're currently examining. Okay, because the insertion point is going to be that point where A is less than it, right? Because we're maintaining an ascending order. So long as both of these conditions are correct, then we're going to increment our I. Okay, and once that while loop's finished, then we found our insertion point. Okay, so let's go ahead and insert the 11 and test our algorithm so far. So while I is less than size, well, we've initialized I, right? Let me do that up here. We've initialized I to 0. Is 0 less than size? False, right? So I contains the subscript, right? The integer for the subscript of where we want to insert our new value. So that's all done, okay? And I is left pointing at the very first element, okay? So we found our insertion point there. All right, so, oops. Let us then add a second loop, and that second loop is going to be responsible for doing the shifting, right, to make room for our new value if we need to make room. Okay, so we're going to need a second variable, and let's call that j, and we're going to initialize that with size. Okay, we're going to start at the end of the list, and we're going to move everything one step or one element to the right. Okay, so j set the size, and so long as j is greater than I. Oops, than I. Not greater than 0, but greater than I, right? Because we don't want to shift. We don't want to shift too far. Okay, and you'll see. We'll walk through it, and you'll see what I mean. Okay, so while j is greater than I, what we're going to do is we're going to say, all right, well, let's set list of j to list of j minus 1. Okay, and then we'll decrement our j. Okay, once that while loop's done, we've shifted all the elements over, and now it's safe for us to assign the value that we want to place in the list, and then we have to increment our size. Okay, so that's our algorithm right there. We've got that step, we've got that step, and that step. And so let's go ahead and just trace through this algorithm and make sure that I don't have any logic errors in here, make sure that it looks okay. So we're inserting 11. So size is less than max, that's true, 0 is less than 5. I gets initialized with 0. Well, I is less than size, well, that's false. So then we create j, okay? You can initialize j with size, 0. So while j is greater than I, false. So that while loop's done. So now we get down to list of I set to a. So I is 0. A was 11 because that's what we were adding. And so our 11 goes there. Now we increment our size variable. Okay. All right, good. That looks good there. All right, so now let's insert another value. Let's do a couple more values here just to do a sanity check to make sure that this works. Let's say that we're going to insert 23 this time. All right, so if we're going to do that, is size less than max? Yes, 1 is less than 5, true. So we initialize I with 0 again. While I less than size, true, because 0 is less than 1. And A is greater than list of I, that's true, because 23 is greater than 11. Then we increment I. Okay. All right, now we go back up to the top of the loop. While I is less than size, false. So we found the place that we want to place the 23. Now let's go to the next loop, the j loop. Initialize j with size. Okay. While j is greater than I, false, right, because they're both the same. So we're not shifting anything to the right, and there's nothing to shift to the right, so that's correct. So then we do our assignment. List of I is equal to A. So 23 goes here, and size gets incremented. Okay, so let's insert one more value. I'll just throw one up here, right, to make this a little bit more interesting. 34. That would mean that our size ends up at 3 after we finish the algorithm. Okay, I just want to put one more value in there really fast to make this interesting. Now let's say that we want to do an insert in between two values. Let's see how that works. Let's say that we wanted to insert 17. Okay, that means that 17 is going to have to end up in between 11 and 23. Okay, now again, we can't put 17 in between two elements. There's no memory location for that, right? You can't just add a new element in the middle of it, right? So what that means is that the 17 is going to go at element 1 after we've shifted 23 and 34, one element to the right. Okay, so let's see how that plays out. All right, so if size less than max, true. Set I to 0. Okay. While I is less than size, 0 is less than 3, that's true. And A of list is greater than I. 17 is greater, excuse me, while A is greater than list of I. 17 is greater than 11, that's true. So I gets incremented. Okay, then we go back to the top of the list. While I is less than size, 1 is less than 3, that's true. And A is greater than list of I. Well, that's false, right? Because 17 is not greater than 23. So we found where 17 needs to go, and it's at element 1. Okay, but before we can put it there, we have to shift 23 and 34 over, and that's what the J loop's going to do. So we set J to size. Okay, while J greater than I, true, because 3 is greater than 1. Set list of J to list of J minus 1. So we're going to set list of 3 to list of 2, right? So 34 goes right there. And then we decrement our J. Okay, go back to the top of the while loop for the J loop. While J is greater than I, true, because 2 is greater than 1. Set list of J to list of J minus 1. So we're going to overwrite the 34 with the 23. Okay. All right, then we decrement J to 1. Go back to the top of the while loop. While J greater than 1, false. 1 is not greater than 1. So our shifting is complete, and now we're safe to proceed to the next step. We'll assign to list of I what's inside of A. And what's inside of A is 17. So list of I, list of 1, is going to have 17 in it. Right? So we overwrite this 23. And we've got our 17. And voila, value has been inserted. Okay, so last step, very last step, increment size by 1. Okay, all right, so that's how it works, right? So there's an example of how this thing works. There's the complete algorithm. Before we finish off with this insert algorithm, let's go ahead and do some analysis. So let me clear some room over here for this. I'll delete you and delete you guys. All right, so how are we going to do the analysis for this? All right, well, we want worst case, right? So in the worst case, one of these while loops is going to execute, but not both. Okay, and what is the worst case? Well, the worst case is either we insert a new value at the beginning of the array, forcing us to shift a bunch of values over one spot, or we insert a value at the end of the array, causing us to have to do a search with that first I while loop to find the very end. Okay, so either way, the worst cases are going to involve us having to use one of those while loops over and over and over again. Okay, so spoiler alert, it's going to be the J loop here, right? Because take a look at the body of the J loop. There's actually two statements that are going on rather than just one statement inside the body of the first while loop, okay, the I loop. So let's go ahead and count some operations here. All right, so no matter what happens, we're always going to check to see if size is less than max. That's one operation. Then we assign 0 to I. That's another operation. And then we have this while loop, while I less than size. That's going to be an operation no matter what. And is going to happen, so that's going to be an operation. Okay, and then A greater than list of I. Now if we're inserting at the very beginning of the list, that's going to be false. Okay, but we still have to copy or count that operation the one time. But since it's false, it means that this guy never happens. So we don't have to copy any of those. Okay. All right, so let's move to the next statement. Assign size to J, that's an operation. And then let's go to the while loop, the J while loop. Okay, now think about what's involved with doing that shift. Okay, so let's say that we've got that many elements right there. Okay, and we want to put X at the very beginning. Okay, of the array. That means that what's going to have to happen is that assume that this array is, or that the list is size minus 1, or I should say max minus 1 for its size, so that and that element are all being used up. Okay, that's going to mean that we're going to initialize size to point here, okay, and we're going to have to do a shift here. That's going to be 1. Okay, then we move j, we decrement j, and then we do a shift here. 2, move j, do a shift, move j, do a shift, move j, right? And then, oops, went too far. Move j, do a shift, okay? And then we have to test one more time to see if j is greater than I, okay? Once j has been decremented to this. That, of course, is going to evaluate to false. Okay, so what does that mean? It means that for each one of these elements, right, we're going to have a test of j greater than I. Okay, so if there's n elements, we're going to have n of those tests. Okay, now only n minus 1 of those tests is going to evaluate the true. Okay, the last one's going to evaluate the false, but it's still going to be tested n times. Okay, now what about the body of the while loop? Well, that's only going to execute n minus 1 times, right? Because the test j greater than I is only going to execute or going to evaluate the true n minus 1 times. The last time it tested evaluates the false, so that body of that loop isn't going to execute that last time. So let's keep that in mind. Everything that we do in the body of this loop is going to be happening n minus 1 times. Let's count the number of operations. Okay, there's 1 there. And there's 1 there, the subtraction. So there's 2 for that. And then the next statement, there's 1 there for the assignment, and then there's 1 there for the subtraction. So there's 4 total operations that are going to happen n minus 1 times. Okay. All right, now we go to the next statement here. Once we get out of that loop, we got an assignment. Okay, then we go to the next statement here, and we've got an assignment and an addition. So that's 2 more. All right, so let's total up that count. And what have we got? 9 plus n plus 4n minus 1. Well, I have to distribute it. 4n minus 4. Okay, let's total that all up. What do we got? 5n plus 5. So the total number of operations of our algorithm here are going to be big O, 5n plus 5, which we can reduce, because when n is infinity, who cares about plus 5? And 5 times infinity is still infinity. So that reduces down to a total of big O of n, which is linear time. Right? A lot slower than doing an insertion on a unsorted list, but we're maintaining the order of the list. Okay? All right, so that's insert. So let's take a look now at the remove algorithm. Okay, we've decided that we want to remove a value from the list, right? So we're going to have the array to remove the value from. We're going to need to have the index of the element that contains the value we want to remove. Then we're going to need to know the current size of the list and the maximum size of the list, right? The number of elements in the array. Okay, so quick reminder, what are we doing here? Right? Once we've identified the value we want to get rid of, we got to shift all the elements to the right of it over one spot so we can overwrite that value, thereby removing it from our list. Okay? All right, so let's draw ourselves up another array here. Okay. And this will be really fast to go through. So let's say that we got 11, 14, 19, 27, and 36. Okay, so that's the current state of our list. It's full. Its capacity is 5, and its current size is 5. All right. So let's say that somebody came along and they decided that they wanted to remove the second element of the list. Okay, so if you're going to do that, then what we have to do is, first of all, we want to make sure that there's actually a subscript 1 in the list. Okay, so let's check that. If A is greater than or equal to 0, right, and A is going to be our subscript, and A is less than size. Okay, so long as the subscript they want to remove falls in between those two endpoints, then we're good to go. Okay, then we can go ahead and do the remove for them. Okay, so what do we have to do? Well, again, we're just going to shift. We're going to need to shift, copy the 19 here, copy the 27 here, and copy the 36 here. Okay, so let's start by setting I to A, right? So I is pointing here, and then we'll reach over to the right and grab the 19 and overwrite the 14. Okay, and we're going to do that so long as I is less than size. Okay, because we don't need, we can't go past the end of the array, okay, or the end of the list. Okay, so what do? We just say list of I is going to be set to list of I plus 1. Right? And then we increment our I. Okay, once that while loop's finished, we will have effectively removed the value. So we need to shrink our size variable. We need to decrement that to reflect the fact that we have one fewer item in our list. Okay. All right. So let's go through and walk through this algorithm, make sure that it works. Okay. Let me see if I can clean all that up without doing too much damage. Okay. So what did we have? I think it was 14 and 19. If not, whatever. Okay. So there we go. So we're going to remove the element at, or the value at element 1, or in element 1. So go into our algorithm here. If A is greater than or equal to 0, that's true because 1 is greater than that. And A is less than size, that's true because 1 is less than 5. So let's initialize I with A. Okay, so I gets initialized with 1. While I is less than size, that's true because 1 is less than 5. So we're going to assign list of I plus 1 to list of I. So we're going to overwrite list of I with list of I plus 1, right, which is element 2. Okay, then once we've done that, we increment our I. And then we go back to the top of the loop. So is I less than size? Yes, because 2 is less than 5. So then we do the same thing. We're going to overwrite list of 2 because I plus 1, oops, list of 2, not list of 3, because I plus 1 is going to be 3. We're going to take that, 27, and overwrite what's inside of list of I. Okay, so 27. Once we do that, increment our I, and then go back to the top of the while loop. Is I less than size? True. So then we are going to assign to list of I, which is 3, the contents of list of I plus 1. So list of I is getting overwritten with list of I plus 1. Okay. Oops. Sorry. So 36. And then we increment our I variable. Okay. All right. So actually at this point, we could stop our loop right now, actually, right? Because what we're going to end up doing is we're going to end up decrementing our size, which would cut that 36 out of the list. And if we had one more iteration at this point, we'd be trying to copy a value from past the end of the array, and we don't want that. So let's make a slight modification to fix this. While I is less than size minus 1. Okay, so that would terminate our loop right now, okay, because 4 is not less than size minus 1. Okay, and then our loop's over. The next step happens and size gets decremented. So size becomes 4. Right? So we're leaving the 36 in position here, not overwriting it because we can't go 1 past the end of the array, right? There is no I plus 1 or 5. There is no 5 here. But that's okay because our logical list is only 4 elements long. The front of the list is always an element 0, so that's part of the list, that is, and that is. Who cares that that 36 is still in there? It's not considered part of our list anyway. Okay, all right, so there's an example of the remove algorithm. You know, trace through the algorithm on your own, trying different combinations of values. You know, verify for yourself that, you know, it works or nothing bad happens on an empty list or on a list that only has, say, 2 values. And you'll see that it holds up. Okay, so let's go ahead and do some analysis here. Okay, let me clear this stuff out of the way. Okay, so let's do some analysis. All right, so analysis. So let's count our operations. Okay, so worst case scenario. Okay, worst case scenario would be if we had, right, if we decided that we wanted to remove this very first element, right? And why is that? Because we'd have to shift all these values over, starting with the very last one, right? Or going through the very last one, I should say. We'd have to shift all these elements over to overwrite the very first one. Okay, so that's the worst possible case. So let's see here. So let's say that we've got 1, 2, 3, 4, 5. We've got 5 elements. That would mean that we'd have to do a shift here. That's 1, 2, 3, 4. Okay, so that means that that while loop is going to would have executed 4 times, right? Or this, if n is equal to 5, because there's 5 elements in here, means that this would have had to have executed n minus 1 times. Okay, so we got an n minus 1 for the less than, but there's also the minus right here, right? So that's going to happen n minus 1 times also. Okay, but before we even get there, we have to check to make sure that a is greater than or equal to 0 and a is less than size. So there's 3 operations right there. And then inside the body of the loop, what do we have? The body of the loop is going to execute n minus 1 times, although now that I'm looking